dive into the lesson of today. So, guys, I promised you to first uh, do maybe some problems that you had or might face when practicing regarding grade 11 Euclidean geometry, which is the circle geometry. But if you guys don't have any question regarding that part of Euclidean geometry, we can just jump into the grade 12 Euclidean geometry. Let me just quickly share my screen. I now shared my screen. Can you guys see the textbook I'm using right there?
Yes, sir.
Oh, okay. So today we are going to do the new chapter, the new topic of which I would love for you guys to listen carefully, cooperate with me, we work together so that you guys understand this new chapter well, because it is there in grade 12 paper, I think, June trial, also in final. Euclidean geometry, as I've said, it contributes a lot of marks. So it will be advisable to you guys that you understand this chapter. So as they are saying right there on top, that in this chapter we will study the concept of ratio, proportionality, and similarity. We will focus on triangles, I think always or mostly. We will learn three new theorems. So now we are just going to work with new grade 12 theorems. We are just going to a bit forget about those that we did, the grade 11 part. At the end of this chapter, you will find a summary of, okay, fine. The triangle proportionality theorem, the proportionality theorem. I love that. So a proportion is a ratio that remains constant when we say that two line segments are divided proportionally, sorry for that, are divided proportionally or in proportion, it means that they are divided in the same ratio. So this we have got this theorem right here on the screen, theorem 1. They are saying a line, this line in this triangle, uh, a line in this triangle. They are saying a line parallel to one side of a triangle. So we can see that this line is drawn and it is parallel to the other side of this triangle. So this line divides other two sides of a triangle proportionally, right? This doesn't mean that this line is equal to this line or this line is equal to this line. It doesn't mean that, but it means that this line AP over PB is equal to AQ over QS. That's what it means. So given this whole triangle, whenever you are given a triangle ABC, you are given a triangle, then now I come to this triangle. I draw the line PQ. That is going to be parallel to this line. Then you can conclude saying that the line, when you take the line OAP, you divide by PB. That ratio is going to be the same as AQ over QC. But remember, this is still Euclidean geometry. And I've said to you, in Euclidean geometry, when you put a statement, you also have to accompany that statement with some reasoning. So they are saying the reason this side is line parallel to the side of a triangle. But mostly I use the reason prop theorem or proportional theorem, and then you state your parallel lines that PQ is parallel to BC. Just to follow up, guys, can you all hear me?
Kind of, sir.
Okay. Do you understand what I've just said, or you want me to maybe re-explain?
If possible, sir. Can you please
Okay,
explain?
okay,
Re-explain.
okay,
Because the network
okay,
here is bad. I can barely hear you.
okay, okay. Let me just try to re-explain it. So we are talking about theorem 1 here on the screen. That is saying a line drawn parallel to one side of a triangle. This is the triangle that we are talking about, ABC. Then we are saying a line drawn parallel to one side of a triangle. Then we can see on our diagram that this is the line that is drawn parallel to this one. Can you hear me?
Yes, sir.
Oh, okay. Let me just continue. Like I was saying, this line is the one that is drawn parallel to this one. When that statement continues, saying this line that is drawn parallel to this one divides other two sides of that triangle proportionally. Then I emphasized this that doesn't mean that AP is equal to AQ. And it also doesn't mean that PB is equal to QC. But it means that when you take the length of this side, which is AP, over the length of this line, PB, is equal to, when you take the length of AQ, you divide by the length of QC, just like that. When we look at this equation right here, you will be wrong if you say this AP here is equal to AQ and PB is equal to QC. But instead, when you take the ratio AP over PB is equal to the ratio AQ over QC. And I emphasized this again that this is still Euclidean geometry. We are still in Euclidean geometry, just that we moved from grade 11 Euclidean geometry to grade 12 Euclidean geometry. But you need to keep in mind that in Euclidean geometry, whenever you put a statement, that statement needs to be accompanied with a reasoning. So this is their reasoning. They say line parallel to the side of a triangle. But I said mostly I will use the reason prop theorem. Then I will state my parallel lines that PQ is parallel BC. Can you hear me?
Yes, sir.
Yes, sir.
Okay. I just want to follow up with others. Can you all hear me, guys?
Yes, sir.
There's this mic that is open. Who's that? Let me just check. Moronga. Is it Moronga or Moronga? Can you please close your mic? And then let me just quickly go back to the lesson. So, did you guys understand what I was talking about? Yeah.
Can you please close your mic?
Hello, guys. Did you all understand what I was talking about here on this
Yes,
theorem?
sir.
Okay, thank you.
Yes, sir.
Then we can just go have a look on these structures or diagrams right there, whereby now they are playing around this proportionality theorem. So this one, the first one, is the one that we talked about right there, that in this triangle right here, you can play around your proportionality theorem that AP over PB, that is equal to AQ over QC. Or you can just flip this. You take a numerator, you make it denominator. You take denominator, you make a numerator. Saying PB over AP is equal to QC over AQ. Note that you can't say AP over PQ is equal to, and then now you come start with this one, say QC over QA. If you started here saying PB over AP, you also on this side need to start on this line QC over AQ. Does that make sense, guys?
Yes, sir.
Okay, thank you.
Yes,
Then
sir.
you can, okay, thank you for the feedback. I'd love to have more of that. If you understand, let me know. If also you don't understand, just shout it out so that we don't leave you behind. So you can play around that proportionality theorem again, saying the whole side AB over this side AP should be equal to, you come again, you say the whole side AC over AQ. Note that again, you can't say the whole side now as a numerator over this side AP is equal to QC over AQ. No, that will be wrong. If you started with the whole side as the numerator of that other side AP, again, on the other side, you need to start with that whole side AC or over AQ. Same applies. You can flip that, make your denominator be the numerator, and make your the numerator be the denominator. Saying that now, AP over the whole size AB now is going to be equal to just AQ all over the whole size AC. Keeping in mind that when you state this statement, you need to put your reasoning here, that I'm saying this because this is the proportionality theorem, and then you state your parallel lines, that PQ is parallel to BC. Does that make sense, guys?
Yes, sir.
Okay, thank you. Same applies with
Yes,
that
sir.
other last. Okay, thank you. With also this other diagram, we are going to play around that triangle. So now let's proceed to this corollary. It's called the midpoint theorem. They are saying now in this one, a line drawn through the midpoint of one side. Now they are saying if this line right here is drawn through the midpoint of one side of a triangle, let's say this triangle AB is of maybe, let's say, 4 centimeters. Then if this red line here is drawn through the midpoint of AAB, it's going to divide or bisect AB. And I think you guys now know the terminology bisect. What does that mean? So it's going to cut AB into 2 equal parts. You are going to have 2 centimeters from P to A and another 2 centimeters from B to P. So if we continue with the statement of one side of a triangle, okay, that's what we did. And then this line here is parallel to other side of a triangle, is parallel to this one. So this line now are parallel. You can conclude by saying now, this line bisects this one. What does it mean? It bisects that one. It also divides this side into 2 equal portions. If we were given that this side here, it was maybe of, let's say, 6 centimeters. Now you can conclude by saying this portion here is 3 centimeters. And again, this portion here is 3 centimeters. Only if you know that this line is parallel to this one, and you know that this line bisects this one. That's only when you can conclude by saying this line bisects this one. Does that make sense, guys?
Yes, sir.
sir.
Okay, thank you. Then let's just quickly now dive into the example right here on the screen, whereby we are having that. Okay, diagram A, B, C, let's say P, Q 15, 10, 6, X. Okay, then let me do this. Sorry. I just want to quickly come to this and draw that diagram. Let's say we are good. No, this is too thick. I want, or better, I want to draw this, and then we have A, B, C, P, Q. And then you're given that this line is parallel to that one. You're given that as 10, not 16. I'm sorry for the bad handwriting. This is 15 units. This is 6 units. This is X units. So in the diagram right here in front of us, we are given the triangle ABC. We are also given the line that is parallel to one side of a triangle PQ is parallel to BC. We are given the length of the sides, AP, again PB is 6, AP is 10, AQ is 15, QC is X. So the question for this one is calculate the size or the length of that QC, which is calculate the value of unknown X. So what you are going to do here, so since we are given that line in this triangle ABC and is parallel to BC, we can simply use a proportionality theorem, the grade 12 one. You put the formula, you put your reasoning, then you substitute, you solve for value X. Just like this, AP, it took the side AP from A to point P all over P, B, that is simply going to be equal to, because we started there, which can I just annotate? I want to wrap that. So because with this one, we started there to this point, over from this to this. Also with that other side, you're going to start from that point A that we started from initial to this line that is parallel to the third line of a triangle over this one. So we are just going to say A Q all over QC. So this is the statement. This is our geometrical statement. Then after, because my space is a little bit small, here on your paper, I think it depends which one you prefer, here or here. You can just put the reason. This is the reason I like prop theorem. And then now you state your parallel lines. PQ is parallel to BC. That's your reasoning. So I will just wrap this reason because of the space. But you are still also allowed to use that reasoning that is on the textbook that is saying line parallel to the side of a triangle. But I prefer this one always. I just enjoyed it when I was doing my metric. So I'll just wrap this reason because of the space. So let us now substitute what we are having from the triangle of the information that we are given. What is AP? It is 10 all over. What is PB? It is 6. And then what is AQ? It is 15. And then what is QC? It is the unknown X. Then now from here, you do your basic mathematical algebra. I mean, 10x is just going to be equal to 15 times 6, which is 90. Therefore, x is equal to, is it 9? Divide by 10, then you get 9 units. Then that's your answer. Does it make sense to everyone, guys?
Yes, sir.
Yes, sir.
Oh, okay, then thank you. We can go to look at other examples. Rub, 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 rub. And then now here we have another example right here. They are saying in the following sketch, right there, we are given that ST is parallel to PQ, and then the ST, we can see that is that line that was drawn in an existing triangle. So anyone with some idea of what we can do to approach this question?
Sir,
Anyone? Yes, sir.
what I'm seeing is that we could potentially, I feel like we could use the ratio over here, sir.
The ratio.
Yes, sir. So
Okay, I'm listening.
since there are
Okay.
parallel lines there, so that means that the division proportion theorem could work over here.
Yes,
So we-
sir.
So we could say that like QR is over PR. So like that could
You are
be the
saying
ratio.
QR over TR, right?
Oh yes, sir.
Okay, is equal to?
QR over TR is equal to PR over SR.
PR over SR, okay.
And then we multiply it out to get TR.
And then you are done just like that?
Well, like, so what you need to do is you have to give reasoning. So like in the beginning you have to say like TR over QR is equal to SR over PR. And then you say division proportion theorem because PR is parallel to ST.
Yes,
And
correctly.
then you
Then,
solve for TR.
yeah, absolutely. Then you can simply do this. So just like you are saying, I don't know if you guys are going to see if I type somewhere, but let me try. You are saying, let me type it here. Here. So you are saying TR over QR is equal to, SR over PR. And then you state your reasoning. This is what you are saying, right? And then
Yes, sir.
you substitute your, TR. We are given that TR is what? Or is the one that we are looking for. So we can simply say TR over QR. We are given that QR is 24 is equal to SR, right? There is 27 all over the whole now of PR, which is 27 plus that 9 gives us 36. And then now when you get here, you play around your maths. TR times 36 is equal to 27 times 24. Then you make TR subject of the formula. But don't forget the reasoning when you put the statement. Does it make sense for everyone, guys?
Yes, sir.
Okay, I can hear the feedback from one person. I think one another is the one who was telling me what to do. I'm not sure about others. Does everybody understand what we just did, guys?
Yes, sir.
Okay, thank you. Then we can just quickly proceed to the other ones. Then now we have got ratios and fractions here, which is a very, very, very powerful useful technique that we are going to use in this creature of Euclidean geometry. So now here they are saying, remember that a ratio can be expressed as a fraction and vice versa. A fraction can be expressed as a ratio. So in that block right here, we are given that AB is to BC is equal to M is to N. We can just write that in a fraction form. Note that in the ratio, what you are given on the left-hand side, when you write that in a fraction form, this is going to be your numerator, this will be your denominator. Is equal to same applies. This will be your numerator, this will be your denominator. Therefore, AB over BC will be equal to the ratio M over N. For example, we are given an example here, guys, that if we are given that AB is to BC is equal to the ratio of 2 is to 3, then you can conclude by saying when you divide AB by BC, you're going to get 2 over 3. Now, there below, we are having problems involving ratios and length, because sometimes they can give you the ratio, sometimes they give you length, sometimes they give you both, and of which you are going to use that ratio to get some length that we don't know, that we are required to find. So they are saying if two line segments are in a ratio, they are in a ratio of M is to N, we can represent their length by mx, and nx, respectively. For example, this is what they are trying to say. Let's say we have this line right here, A, B, and then point K right there. And then you know the ratio that A, K is 2, K, B, their ratio is maybe 2 is to 4. You can simply write that ratio as 2, maybe introduce another variable, maybe y is to 4y. Maybe it doesn't make sense now, but I will try to emphasize it when we use it to some problems, this. And then we can just proceed. So in this block right here, they are saying now, if AB is to BC, oh, it's what we said, but let me just repeat it. If AB is to BC is equal to M is to N, you can let that ratio for AB, M, times it by a variable X or any variable. It doesn't necessarily need to be X. You can introduce any variable of your own, and BC be an X. But note that if this is a side that you are dealing with, this is the side that you are dealing with, A, B. Let's say this is C. And then you have 7, and then you introduce the variable K for AC. Let's say this was 3. You cannot introduce maybe a different, sorry for that. You cannot introduce a different variable, say maybe this is 3L. If for this side, you introduce the variable K. Also for this one, it needs to be K. So for that whole side will be K. If you introduce X for that whole side, it needs to be X. Okay. Then now we go to this other example. They're saying AB is to BC is equal to 2 is to 3. We let AB be 2X. And then now we cannot let BC to be maybe 3Y or 3L or 3O. It needs to strictly be the same variable as the one that we introduced to AB. So it will be 3X. So they're just saying this technique is important, just like I've said. So we've got example 2 right there on the screen, whereby in the sketch, this is the sketch that we are given right here. In the sketch, we are given that AB, where this is AB, oh, sorry. This is AB, AB is to BC, it's a ratio. It's not the length. AB over BC is equal to 7:3. It's only the ratio, is not the length, because you cannot say AB is 7, because we are given the length of AB here as 21. Okay, and then now the size of all this size, which is AE, is 20 units. Okay, that's all info. That's the only information that we are given. Then here we are required to calculate the length of BC. This is the example that we are having right in front of us, that AB is to BC. It's 7:3. Then that whole side, that ratio, you can introduce those variables just like they did here, that AB, its ratio was 7, then BC was 3. We give them a variables because they are the same, they are sides of the same line. You must give them the same variable. If you give this first one X, also the second one must get X. So AB will be 7X, BC will be 3X. Then now, we know that this side, A1, is 21. And we know ratiocally, I don't know how to say it, but from that ratio, we know that AB is 7X. So you can just say now AB is equal to AB. That's what we know. And then AB, in terms of ratio, we know that it's 7X. In terms of the length is 21. Then you solve for that value, X. You're going to need it. This is 7 divided by 7. Then you get your X as 3. So after getting that X, let's maybe dive into the questions and see if maybe we can use that value of X. The question is saying find the length of BC. Okay, when you go to the BC that we had the BC of the ratio, which is 3X, and then now we know what the value of X is. We found the value of X right there using the ratio and this length 21. So the value of BC is going to be that 3 of X times this 3 right here of the ratio. Does it make sense, guys?
Yes, sir.
Yes, sir.
Okay, does it make sense to everyone? Because I think I only heard the feedback from 2 people. Does it make sense, guys, who didn't give me a feedback?
Yes, sir.
Yes.
Oh, nice. Thank you.
Yes,
Then we can, okay, thank you for the feedback. I love that. Then we can proceed to the next one now, number B, whereby now we are required to find the ratio of AG over GD. Then they did this example right here. They are saying AB, here is AB, is to BC. We can write that ratio in terms of a fraction, which is going to give us AB over BC. Then using a proportionality theorem in that triangle ACD. And then we can see that BG is parallel to other side of that triangle. BG is parallel to CD. Then you can just use proportionality theorem that AB over BC is equal to AG over GD. Then that was a statement in here in geometry. You are accompanying that statement with a reason that line parallel to the side of the triangle by proportionality theorem. Oh, I'm sorry, who is that? Can the person who opened the mic please close the mic because it's a bit disturbing me? Okay, thank you. Then So like I was saying, now because we have got this triangle and we can see that there exists a line BG that is parallel to the other side of a triangle is parallel to CD, then proportionality theorem is applicable. You can simply say now AB over BC, and you already have that, is equal to the ratio AG over GD, the ratio that we are looking for. Then that was a statement in Euclidean geometry. The statement needs to be accompanied by a reason. So you state your reason. Parallel line is a line parallel to the other side of a triangle. Or proportionality theorem, then you state your parallel lines that BG is parallel to CD. Nice. Then now what was AB? Then you go to the ratio that we had. It was 7 over, AB, it was 7, then BC, it was 3. That same ratio is going to be the same ratio of the sides that we are looking for. The ratio doesn't change. The only thing that is going to change is the size of the side. Maybe if we are saying AB is 21, just like we are given that, we can't say AG is equal to AB. The length of the sides are going to be totally different. The only thing that is going to be the same is the ratio. So does number B make sense, guys?
Yes, sir.
Okay, thank you. Then we can proceed to number C, which is saying calculate the length of FE, and then we are going to play around that ratio. Now they are saying because we found the ratio of AG over GD. Now we can move from this triangle ACD. We are now going to that other triangle ADE. We are going to use this line AD with that line AE. So we are going to say AG over GD is equal to, I'm sorry. Okay, we can't use that, or we can, depends on how you see this or how you can easily manipulate that, because we also have the whole side or size of AE. But here is an example that they did. They are saying AG over GD is equal to AF over FE. Then you give your reasoning. Line parallel to the side of a triangle, or proportionality theorem. Then you state your parallel lines that GF is parallel to DE. Then the ratio for AG over GD was 7 over 3. Same applies to this equation. The ratio of this is equal to the ratio of this. That simply tells us that the ratio of AF over FE is going to be 7 over 3. When you write in a ratio form, AF is to FE is going to be 7:3. Then now you can introduce a variable. Then now this is what you need to note. These lines, this line, we introduced the variable x for this one. Then if maybe you wanted to introduce the variable for this one, because already for this one you introduced x, you are not supposed to introduce x for this one, but instead maybe you let it be y or z, but any other variable that you didn't introduce. Again, when you move to this other one, you don't introduce the variable that you already did with this side. So we already used x. That's why they didn't use x for that one. They used y. So okay, sorry for that. So they introduced the variable y, that AF is to FE, that is 7:3. Now AF will be 7y, and then FE will be 3y. AF cannot be 7x, FE cannot be 3x. We already used x on that other proportionality side. So we introduced y, that AF is 7y, FE is 3y. Then the whole side, now we can use that the sum of AF plus FE to solve the value of y. We equate that sum to this 20 that we are having right here. we can just take this side, AF, which is 7y, plus this one, which is 3y. It's just going to give us this 20, just like they did here. And then you solve for the unknown value, y. And then you go to the question, look what they want. They want FE. FE in a ratio form, we had 3y, and then you already found the value of y right here. Then you substitute to that. You find the value of size and length FE. Does it make sense, guys?
Yes, sir.
Yes, sir.
Oh, okay then. Okay then. Thank you. We can just quickly move to this example here, and then now I would like us guys all to just work together around this or have conversation around this problem, and not like the other ones I tried to explain it. But I would like to hear from you now, guys. But okay, we are reading the statement now. We're saying in the sketch alongside that we are given. We are also given that the line BE, which is this one, is parallel to this one. We are also given this one that is parallel to this one. Then now I would love to hear from you. How do you guys think we can find the length of that ED and the ratio CG is to GD, given that BC is equal to 3 over 5 times AC, and we are given the length of AE as 16 meters and EF as 10 meters. Anyone with an idea of how we can find ED? Anyone with an idea, guys? Play around proportionality theorem to find the length of ED and the ratio CG is to GD. Given that the line BE is parallel to CD, and again CE is parallel to GF, we are given other information that the length AE is equal to 16 meters and EF is 10 meters. BC is equal to 3 over 5 AC. What do you guys think?
Sir, can I try?
Okay, you can give it a try, sir.
Okay, since we're given BC is equal to 3 over 5 AC, let's just divide by AC. Let's just divide by AC. That way, BC over AC will equal to 3 over 5.
Okay, that's a good approach. That's a good approach. I love it. Okay. Yes. And then now what do we do?
Okay. Afterwards, okay, so then we'll equate it. We'll say since we have BC over AC, our ratios, we have our values. We'll say BC over AC, which will
BC
equal to
over AC.
looking at the parallel lines, we'll say BC over AC will equal to ED over AD. The reasoning, the lines parallel to the side of the triangle, which is BENCD.
Okay, correct.
Therefore, since they're parallel, therefore ED over AD is equal to 3 over 5.
3 over 5 is equal. Okay.
Or in ratio terms, ED as to 5. 3 as ED as to AD. In ratio terms, it's the same thing as 3 as to 5.
Okay. Yes, I agree.
Oh, sorry. Sorry. So now, sorry, I'm really sick. Oh. Now then, remember, that's not our final answer. Those are just the ratios.
Yes.
So let AD, since we know that ED, let me just say let ED equal to what? 3A, and I'm just making an example. Let
Okay.
ED is equal to 3A and AD is equal to 5A, because those are just the ratios. That's not the full length.
Letting ED be 3A.
Yes, you can use any shape.
And
You can use any letter, it's fine. You can use any letter, it's fine. These are just the
yes.
ratios.
Okay. Yeah.
So next thing, sorry. Next thing is now that we have 3A and 5A, we can find, sorry, we can find AE, which is what? AE is the accumulation of AE is the accumulation of AD and ED. So all we can say is AE is equal to 5A minus 3A, which is 2A.
Yes.
Then
Okay. Correct.
afterwards, however, we do have AE, which is 16. So let's equate
Yes,
two A, let's equate 2A equals to 16. Divide both sides by 2, you'll get 8. That's
for
our
A,
A value.
right?
That's our A value.
Mm-hmm.
Then you multiply, then we go back to our ratio, 3A. We substitute 8 to 3. So 3 times 8, it's 24 meters. Therefore, the length for ED is 24 meters.
100% correct, sir. So, do you guys understand that? We need to go back and re-explain that.
Sir, can you please show the diagram fully?
Oh, okay, okay. Let me just. Is it clear now?
Yes, sir. Thank you.
Oh, okay. So, do you guys all understand how we found the value of ED?
Yes, sir.
Yes, sir.
Okay, then now anyone with an idea of how we can get CG is to GD. CD is to EG right there. That's the line on the bottom, the horizontal line. Anyone with an idea, guys? CG is to GD. Bum, 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 bum. Bum, 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 bum. The clue, we have ED. I mean, yeah, we have ED. We have EF. You can play around that side to cook something. After you cooked something, you can link that side of EFD with this side of CGD. What do you guys think? You have ED, you have EF, and you have FD. You can find that. You can play around that triangle DCE.
Can I try again,
Okay,
sir?
yes, you can give it a try, sir.
Okay, sir. What we're gonna do, if we're looking for CG and GD, let's look
Yes,
at our
sir.
parallel. Let's look at our parallel lines, CE and GF.
Yes.
So what we're gonna do, we're gonna say CG over GD is equal to EF over FD. The reasoning, lines parallel side of the triangle, which is CE parallel to GF.
100% correct. Yes, sir.
However, sir, we have EF, which is 10 meters.
Yes.
FD, we only have the ratio. But in the last question, we calculated A, which was 8.
Yes, sir.
And our ratio for FD will be what? Sorry. Sorry. Really, I'm sick. Will be what? Will be 24. ED is 24. ED was 24, right?
Yes,
Then
ED was 24.
Sorry. Then we'll have to minus. However, we also have FEF. So what we're gonna do is FD is equal to 24 minus 10, which is 14 meters. That's the distance between FD.
For FD, yes.
Now, what we're gonna do, we're gonna say EF over FD. is equal to 10 over 14. If we
Okay.
simplify it, it's what? What's my calculator? It's 5 over 7.
Okay, yes.
So therefore, since CG over GD is equal to EF over FD, the ratios for CG over GD is equal to 5 over 7.
100% correct. Okay, that is in fraction form. Then you are required to put it in a ratio form. Then you can simply just say it's 5:7.
Yes, sir.
Yes, 100% correct. That's a good approach. I love it. So does everyone understand that?
Yes,
Or
sir.
or is there anyone who's a little bit lost? Do you all understand what we just did right now, guys?
Yes, sir.
Oh,
Yes,
okay,
sir.
then any question that you guys are having, maybe regarding what we just had with the lesson of today? Or we are all cool?
No questions from me.
None from me,
Oh,
sir.
I would have loved to have
No,
questions. You
please.
guys always say you don't have questions. Please, guys, next time come with some questions to just have fun in the room of maths. I think we guys will end up here for today if you guys don't have any question. What I will just forward the homework for you guys to do, and then we will do the corrections first with the upcoming lessons before we can continue with the lesson. If you guys don't have a question, we can just end here for today. Thank you for being with me today or tonight. Have a good night.
Yeah. Thank you, sir. Good night.
Oh, cheers.